So we have this 300 Newton pair. We have a 400 Newton pair. And then the 200 Newton pair. So keep in mind the rules for couples are that they must be equal and opposite forces. So these are both 300, one up, one down. I'll have a coordinate system here. Right and left for the 200 and up and down for the 400. If they were not both 400, we could not treat this as a couple and we would just leave it them as individual forces. Same thing with the 300 or the 200, or if this wasn't exactly to the left but was a little bit askew, then we would not be reducing the 200 pair because they would not be completely opposite directions. So in this case, we can identify them 3 pairs of equal and opposite forces. So what we want to do is externally have the same picture, and instead of having 6 forces, we're going to have a single couple acting on the system that externally is identical to this happening. So we can go one pair at a time and see what's the couple, or how can we reduce each of these pairs into a single couple. So we're going to use the scalar approach here. Is going to be the easiest way to do it. So we just go one pair at a time. So let's start with the 300 Newton pair. So the force, again, they have to be the same. The force for that one is going to be 300 newtons. And then find their perpendicular distance. In this case, it's pretty easy because it's just one up and one down. So this distance here is their perpendicular distance. So it's the perpendicular distance between their lines of action, is another way to think about it. So their lines of action are 5 meters apart perpendicularly. Now, with the scalar method, just like we saw for moment about point in 2D, we have to look at, is this couple going to be positive or negative, clockwise, counterclockwise? So we want to think, if this beam were here and not connected to anything, would this pair cause it to spin clockwise or counterclockwise? Right, so we picture here, where's this? So we put it this way. This beam would want to be spinning clockwise. So this is actually going to be a negative couple. So this simplifies down to negative 1,500 Newton meters. All right, so that's the effect just of the 300 Newton. What we're doing is doing them all separately and then kind of superimpose them together. So C2, it doesn't matter what order I do it in. I'll look at the 400 Newton couple, or the 400 Newton pair. So their magnitude is 400 newtons. The perpendicular distance between their lines of action is this 2 meters here. Again, if I just look at what they do to the beam, if I only were applying these 2 forces, then the beam would want to be twisting in a counterclockwise way. So this is going to be a positive couple that they produce. So counterclockwise rotation, it would cause. So we can reduce that couple to a positive 800 Newton meter couple. So again, keep in perspective that the moment or the couple is the force times the distance. Even though these have smaller magnitude, they're further apart, so the couple they produce is larger than the 400 newtons, which are closer together, which only produce an 800 Newton meter couple. All right, so finally, the 200 Newton pair. So their distance, their perpendicular distance between their lines of action is 0.2 meters. So we'll multiply by 0.2. And then if these were the only 2 forces acting on the object would want to spin in a clockwise direction. So this is also going to be a negative couple here for the clockwise. So putting this together, we get negative 40 Newton meters. Any questions on going one at a time, finding what's the equivalent couple due to each pair? Right, so this is all happening simultaneously, so we want to put all of these effects together to get the net effect of all of this going on the beam. So since everything has the correct sign with it, we just add those three couples together to get the net effect. So this all comes together to be negative 740 Newton meters is the net couple from these three pairs acting. So I can simplify this all down to that single couple. Yeah?
Can you name that CNET?
You name this. Yeah, so you can call it, in this case I didn't write everything out right, so you could just call it C or CNET or something like that. So what we can do is now we can simplify our picture. We have that the result of having this all happen. Like I said, it doesn't matter externally where you put this, so for the sake of argument, I'm just going to put it at the end of the beam, but I could put it at this end, in the middle, or I could put it off the beam. Externally, it won't matter for this class. In EMAT 213, it does make a difference. It's negative, which means that this couple is going to be clockwise. So I can draw this to be my equivalent external response.